Okay, so let us look at another two examples. First one, I toss a fair die twice and obtain two numbers x and y. Let A be the event that x equals 2. B be the event that x plus y equals 7. And C be the event that y equals 3. So the problem has 4 small parts. First part, it asks us, are A and B independent? Or part B, A and C independent? On part C, B and C independent? And last one is are A, B, and C are independent? So those are the 4 problems. How do we do that? Well, so when I toss a fair die twice, noticing that the sample space is going to be what? It's going to be, you can do 1, 1, 1, 2, right? 1, 3, 1, 4, 1, 5, right? Or 1, 6. And then don't you agree you can do 2, 1, 2, 2, right? You can continue of this up to the very end. You can have, 16, 6, right? So in other words, the sample space, it contains 36, right, elements. So the cardinality of the sample space, which is 36, we know that. Going back to the event A, it said that since x is 2 numbers, right? And then, so we can view x as the first number I got, y is second number. So when x equals 2, what do we get? You see, we can have 2, 1 here. We can have 2, 2, right? 2, 3, 2, 4, and then 2, 5, and then 2, 6, right? So that's everything for the event, right? All the possible outcomes for my event A. What about my event B? So x plus y equals 7. Well, if I got the first one is 1, then the second it must be 6. If I got a 2 here, it must be a 5, right? Because x plus 7 must be 7. If I got a 3, this must be a 4. If I got a 4, second one must be 3. If I got a 5, the second one must be a 2. Well, if I got a 6 first, then the last one, the second one, it must be 1. So that's it, right? That's everything. Cool. Event C is y equals 3, right? So C, as you can see here, it's gonna be 1, 3, 2, 3, right? 3, 3, 4, 3, fine. 5, 3, okay, better. 6, 3, good, right? So that's all I see here. And clearly, you can see that the A intersect B is what? So A intersect B So as you can see, A intersect B, I only have one common element, right, which is you see it's 2 and 5, right? So A intersect P is going to be the event which contains only one element here. And okay, so the probability of A intersect B. So do you agree that it's the cardinality over the cardinality of the sample space, which is 1 over 36, right? Now, what about the probability of event A, which is the cardinality of A? So 6 over 36, right? Which is 1 over 6. What about the probability of B? So which is still, we have 6 over 36, which is still 1 over 6. Hence, what we can get? Since P of A intersect B equals PA times PB, do you agree that A and B, hence A and B is going to be independent, right? It's going to be independent. Okay, cool. Now, let me get another paper to write the following part. So we're going to find what about, so part A is down. What about part B? Are A and C independent? Well, let's check. So A is here, right? As you can see here, A intersects C. If you take a close look here, A intersects C. So I gonna only have it to this 2, 3, right? Do you realize that? That's the only part. So it's gonna be 1, 2, 3. And we can use a similar idea. You can easily to drive the probability of A intersects C is going to be 1 over 36. And the probability of A, it's 6 over 36, which is 1 over 6. The probability of C, which also is 1, 2, 3, 4, 5, 6. So it's a 6 over 36, so it's also 1 over 6. So this is still true, meaning A and C are also independent. Okay. Now keep going. What about a B and a C? Okay. So still, I'll put it here. Now maybe we use this paper. We're looking for B and C. Okay. So B intersect C. Let's starting to do the counting here. So B intersect C. As you realize that it's gonna be only this 4 and 3 here, right? So it's probability. And easily you can try that the probability of B intersect C is 1 over 36 is equal to the probability of B times the probability of C, which is 1 over 6 times 1 over 6. So hence B and C are also independent. Okay, independent. Okay, cool. Lastly, how do we check? So go back to here. Are A, B, and C independent? Okay, so this is the part, last part. How do we check that? Well, we need to first realize that what is the A intersect B intersect C? Well, as you can see that A intersect B here is 2, 5. B intersect C here is the 4, 3. So easily you can drive that A intersect B intersect C, actually there's no element there. Okay, so it's an empty set. So the probability of A intersect B intersect C, since it's empty, so it's going to be 0, right? However, we know that the probability of A, it equals 1 over 6. Probability of B, it also equals to 1 over 6. Probability of C, same thing, equals 1 over 6. Okay. So if A and B and C are independent, so it's going to satisfy PA times PB times PC, right? But as you realize that this side is equals 0, but this part is 1 over 6 times 1 over 6 times 1 over 6. It's going to be 1 over 216. So in other words, this is not true. Okay. So hence, what we can get, since this equation does not hold, we can see that A, B, and C not independent. Okay, not independent. So that finished this example. Okay.